In this lesson, we're going to examine a geometric series. A geometric series is the sum of a geometric sequence. So like arithmetic sequences had their own series, so do geometric. Just a reminder that the sequence is the terms. When you add them all together, you get the sequence. And it's going to look like this. Our equation. Our equation has the same letters we've seen before. So Sn is the sum of n terms. And we're going to use un times r to the n minus 1. Make sure this part's in brackets. We're going to have to apply BEDMAS. Okay, that's important when we do this. And we're going to divide all of that by r minus 1. So I'll try a simple one to get ourselves started here. So I want to find S12, the sum of the first 12 terms. So u1 is 3. To find r, we can do u2 divided by u1, which comes up to 6. So 6 to the power of 12 minus 1 all over 6 minus 1. As I was saying, we're going to have to apply BEDMAS, so we need to do this up inside the brackets first. You can use your calculator if you really wanted to do all of this, but if you're not positive on how to use your calculator, you want to do it in stages, just make sure you apply BEDMAS first. You can get some really big numbers when you do geometric sequences and series, because they grow exponentially, so don't stress if you get these really big numbers. The answer to this one is 1,306,069,402. Some of those first 12 terms. That's a pretty simple one. Unfortunately, they're not always so simple. Sometimes you come across fractional things. That's okay. We'll look at a fractional one here. I want to find S9 for this sequence. So my first term this time is 1/5. Now, there's nothing wrong with using fractions, but decimals sometimes are a little bit easier to work with. So I'm going to turn U1 into a decimal. 1/5 is 0.2. R is 1/25 divided by 1/5, which if you use your calculator, use decimals, comes out to, well, it's actually negative there, sorry, negative 0.2. Okay, so in brackets, my R value needs its own set of brackets to the 9 minus 1. I need that second set of brackets to remind myself I need to apply the exponent to the sign. R is negative 0.2 minus 1. Okay, so this one's a little bit messier, right? It's hard to write out all the decimals. So instead, this time, I'm going to work inside out. I'm going to do, it's my calculator, the part inside the brackets first. So negative 0.2 to the power of 9. And then I'm going to subtract 1. So I get a big long answer. But instead of writing it all down, I'm just going to multiply that by 0.2, that part outside. And I'll write down that number. So negative 0.2, 1, 2, 3, 4, 5 zeros, 1, 0, 2, 4, all over negative 1.2. And 2 negatives will make a positive. And if I divide that, I end up with negative 0.16666, and it keeps on going. So we'll go 3 sig figs for this one, and I get 0.167. Okay, so that one's a bit of a messy one. And you're going to come across messy ones, especially when you have fractions involved. And that's actually a nice fraction, because it came out to a decimal that we could work with. Imagine if it was a third or something like that, right? You have to use fractions all the way through the question. Okay, try another one. Find the sum of the series given by this equation, or this sequence, right? So the difference here is we don't know we don't know n. How can I find Sn if I don't know what n is? So as we do with arithmetic things, we have to go back to the UN equation. So our UN equation was this. If we want to solve things about the sequence itself, we have to use the UN equation. So we know the last term is 15, our first term is 960, our R is 0.5. Remember we solved these by doing our guess and check method, right? So we can take this and divide by the 960, make life a little bit easier. If we do that, we end up with 0.015625 equals 0.5 to the n minus 1. Our guess and check method, we use 0.5 to the power of what? It comes out to this thing. If we try it, we get 0.5 to the 6. If our bases are the same, our exponents have to be the same. So we're going to solve the exponents. And n is 7. Once I know that, I can go to my equation now and say, okay, well, what's S? Oops, not 9. S7. So we'll get U1, 960, times R, 0.5, to the power of n is 7, minus 1, over 0.5 minus 1. Okay, this time I'm going to use my calculator the whole thing this time, remembering to put brackets around the bottom part, or think of it as just the number negative 0.5, that'll work too. And it comes out to 1905. There's our equation. Okay. All right, some applications, some word problems. The population of a city increases each year by 2%. Percents are hints that we're doing geometric things, where you're multiplying by a ratio. If at the end of the first year the population was 300,000, determine the population after 5 more years. There's kind of a key there, more years. Now, one of the challenges for us is trying to decide which equation to use. Is this a SN equation or is this a UN equation? Do I want a term of the sequence or do I want to add all the terms to the sequence together? And in this case, we actually want to find a term in the sequence. In fact, we want to find term number 6. We know our first term is 300,000. If we go 5 more years, that gets us to U number 6. Right? Not the challenge there is 5 more years, right? Not just the 5th year. That would be U number 5. So to find U6, we're going to do 300,000. Our R value, R equals, if I want to increase by 2%, I got to take my 1 and add 2%. That's a decimal, it's 0.02. So there's my R value. And I want to do 6 minus 1. And so we can put that into our calculator. And we'll get 331,224 people. And so our trick here is noticing that this is actually not an S equation. The word we want to usually come across for an S equation would be the word total, or the sum of, or added together, or some situation where you have to add up the terms. And that's one of the tricks is trying to figure out if we use the U or the S. So let's look at the next one. In a lottery, there are 10 prizes. First prize is $25. Each prize is double the preceding prize, the one before it. What is the total amount? Well, there's that keyword we're looking for, total. That tells me it's an S equation. So S10. It's geometric because I'm doubling. That's my rate. So starting at 25, I'm going to do 2 to the power of 10 minus 1 over 2 minus 1. That's kind of nice on the bottom because it only comes out to the number 1, right? So I only really need to worry about the top. So if I put this into my calculator, I end up with $25,575. There's an application of something geometric. Let's try another one. The profits of a company after their first year production was $1 million. The company expects to increase profits by 10%. Oh, there's that percent again. Find the profit after 6 years. Okay, so is that a term or is that the sum of? The fact that it's saying after 6 years tells me it's a term thing as opposed to the total for 6 years. So I want to find U number 6. This time I'm not doing 6 more years, so it really is just U6, the 6th year. What happened then? So what do we start at? We start at a U value of $1 million. My R value is going to be at 1, plus I need to increase by 10%, plus 0.1 to the n minus 1. Into our calculator as we go. The number in the brackets I'll just use as 1.1, make it a little bit easier. And I end up with a profit of $1,610,510. Okay, part B, find the total profit. Oh, there's that word again, total. That's an S equation. S10, in fact, so I want the sum of the first 10 years. So U1, $1 million. R, 1.1 to the n minus 1 over R minus 1. Now again, I can do this all in one step in my calculator using brackets. Just think of the number on the bottom as the number 0.1. And if we do, we end up with 15,937,424.60. Okay, that's an S equation. Okay, last one. Consider the geometric sequence, 16, 8, A, 2, B. Write down the common ratio. That's simple enough. We can do that. R is U2 divided by U1, so 8 over 16, that's 0.5. B. Find the value of A and B. We can do that. A is following our pattern. We're cutting in half each time, so A will be 4, and B will be, I'll fix this bracket here, get rid of that. B will be half of 2 is 1. That was pretty straightforward. Let's try part C. Here's what our real question is. The sum of the first n terms is 31.9375. Find the value of n. So when we add all these terms together, when we find the sum, it comes out to that. So we need our sum equation. 31.9375 equals u1 times r, which is 0.5, to the n. I don't know that part. Minus 1 over 0.5 minus 1. We need to solve this. So here's what we can do. Let's simplify the right-hand side first. Underneath the fraction, and I get the number negative 0.5. So I'll do that first. Oops, I put that back in the wrong spot there. 0.5 to the n minus 1 over negative 0.5. Now, I can divide the 16 by that negative 0.5, and it'll come out to negative 32. That will make my life a little bit easier. Okay, so I'm going to divide that 16 by the negative 0.5. And then I'm going to divide both sides by negative 32. If I do that, I end up with negative 0.998. I keep all my decimals here, okay? 0.46875 equals 0.5 to the n minus 1. Well, if I bring that 1 to the other side and I add it, and bring this one here over here and add it, we're going to get 0.0001953,125 equals 0.5 to the n. Well, that looks like an exponential equation. I can solve this by using my guess and check. And I know there has to be an answer that comes out to 0.5 to the power of something because it's the sum of a sequence. It's not a decimal answer. So guessing and checking, 0.5 to the 9 comes out to the 0.0019 value. Well, if my base is the same, my exponents are the same. There must be 9 terms in this sequence. Now, if I had some technology available to me, I also could just put this in my graphing calculator and think of this as y1, and all of this is y2, and solve it that way. It would work just as fine. But if I don't have technology, I can also do some guessing and checking method to solve the exponential equation. Okay, here's your homework. Give it a try, see what you can do. These are all things you should be able to do at this point. And then we'll move on to some other topics in this topic.